My name is Cassandra.
And my name is Gabrielle.
Today we are going to talk about model flutes and xylophones.
This is what a model flute looks like. If I move the wooden dowel, do you think the sound will be higher?
Neelam, if you move the wooden dowel up, do you think that the sound will be higher? So you're right. So notice that the higher up Gabrielle moves the wooden dowel, the higher the sound.
So the lower I move the wooden dowel, the lower the sound.
So when you move the wooden dowel down, there's more air, and when you move the wooden dowel up, there's less air. Do you think if there is more air, then the sound would be high or low? Low. There you go.
Yes, the more air, the lower the sound.
And the less air, the higher the sound.
Would you like to try?
Very good.
This is the model xylophone. Do you think the biggest nail will be higher or lower?
It's lower. Very good. Okay, so a larger nail makes a lower sound.
So a smaller nail makes a higher sound. So why do these instruments create different sounds? Do you want to take a guess?
Xylophone and the flute, you blow into it.
What?
The answer has to do with frequency.
Frequency determines the pitch of a sound.
Since the snail is larger and heavier, it creates a low frequency.
The same thing goes for a model flute. It creates a column of air which results in a sound.
There's one thing we have not gone over yet.
When I tap the snail, it causes a vibration.
Do you know what a vibration is?
Yeah, it's where it vibrates. And that's how it makes a sound.
Close. Yes, actually. Vibrations are molecules that move closely together to make a sound. Vibrations come from all instruments.
All sound starts in vibration.
We hope that you have learned a lot about model flutes and xylophones.
Welcome to the Flutes and Xylophone exhibit. And this is our poster right here. My name is Eliza. And my name is Sabrina. Do any of you play an instrument?
I play the piano.
Okay, so have you ever wondered how pitch can change in different kinds of instruments? The model xylophone has 3 different nails that are different sizes and thicknesses. When you tap the biggest nail, the pitch is slower because it will vibrate at a lower frequency. You can try it out. So did you find that out?
Yeah.
The opposite is true with the smaller and lighter nail. It will have a much higher frequency. Frequency tells us the pitch of a sound. Now we are on to the model flute. Do you see the wooden pole in the model flute? Yes. It creates a column of air through the flute and that produces a sound. Try it out. Good. A flute is a wind instrument. The closer the wooden pole is to the instrument, the higher the pitch is. The further away the wooden pole is from the instrument, the lower the pitch is. A wind instrument is an instrument played by someone blowing air into it, and that produces a column of air to vibrate, causing the flute to make sound. Because this is a model flute, you use the squeaker to make the sound. You press the squeaker down, and that makes the air go through the white tube, going through the clear tube, and that makes the column of air. The xylophone is a percussion instrument. A percussion instrument is an instrument played when you hit or strike it. So now we're going to give you a little quiz. You may use the metal instruments to help you. Does the largest nail of the xylophone have a high pitch?
No.
Good. Does the wooden pole of the flute create a column of air?
Yes.
Good. What makes the pitch high in a model flute?
When we get close to the little white piece.
Good. We hope we taught you a lot today.
How do you think wind and percussion are
When you move the dowel higher up the tube of air, it projects a higher sound.
When percussion instruments are hit, they vibrate, projecting the sound. When you hit hard, you get a louder sound. When you hit softer, its sound is softer. It also depends on the length and width of the nail or object that you're striking. For instance, if the nail is longer and wider, it will make a lower sound. If the nail is shorter and skinnier, it will make a higher sound. This is because when the nail is longer and wider, it is heavier, so it can't vibrate as fast. Whereas when it is shorter and skinnier, it is lighter, so it can vibrate faster, making a higher sound.
Who would like to try the flute?
You four can.
Hope you have a great day.
Welcome to the 5th grade Science Expo. Is there ever a time when you could not hear sounds?
No.
If there's no medium for sound to travel through, then the noise caused by sound will not be heard. Do you know what a medium is?
The surrounding air.
Close. A medium is a liquid, solid, or gas. It is basically anything a sound can travel through. On the right, there is a bell. Surrounding the bell is a glass jar. What do you think will happen if the air is removed from the jar?
The bell will get softer.
Good job. Let's find out. Now listen carefully as I remove the air from the jar. Since there's no air inside the jar, it becomes a vacuum. The top sticks to the bottom. There's a nozzle here, and I am feeling over the nozzle because the air is coming out from the nozzle. Would anyone like to feel? Is the bell breaking, or is it playing loudly?
It's not burning.
Right. As the air will drop, the noise faded away until it's very hard to hear it. Even though the bell is still ringing, you cannot hear it. But what do you think would happen if I were to add the air back into the jar? Let's find out. You can hear the bell again. Another example of where there's not any media for sound to travel through is space. Every day there are many violent explosions that take place on the sun's surface. Luckily, we are not able to hear these awful destructions. Do you know why? Because the sound by the explosions cannot travel without air, and in space there isn't any. So we can conclude that without media, sounds could not be heard. Thanks for stopping by. Thanks for stopping by.
Hi, my name is Maria.
Hi, my name is Mariana.
How does the medium affect the volume of a sound? Well, if there is no medium, then there is no sound. A medium is a gas, liquid, or solid that the sound can travel through, creating a vibration into a sound wave into a sound.
As you can tell, the bell is kind of loud at first. Observe.
We're putting our hand over this nozzle because air is being sucked out of this jar and is coming out here. When air stops coming out here, that means that there's no more air left to come in.
Does anybody want to feel? Don't touch it.
What do you think happened to the sound of the bell? Is it broken?
No.
What happened to the sound?
Well, since the air was coming out, there was no air left into the jar, so then there was.
Well, the bell got softer, right?
Why did the bell get softer?
Because there was no air left in the jar.
Well, like we said earlier, the medium is what the sound waves vibrate off of. If there is less medium, then there is less for the sound waves to vibrate off of. Therefore, there is less sound.
Therefore, if there was so little air or medium, the sound would be so faint you could barely hear it.
The air pressure demonstrates that the air is out of the jar.
So that explains how the medium can change the volume of the sound.
Let's review. In step 1, we had a loud sound, a pronounced sound wave, and more air. In
step 2, there was less air, so it was a softer sound and a less pronounced sound. In step 3, there was barely any air, so there was almost no sound and barely a sound.
As we release the air, the bell gets louder again. Thank you for listening.
Hi, my name is Katie.
And my name is Abby.
We're going to talk to you about air affecting sound.
Have you ever wondered how air affects sound?
When the bell is out of the jar, is the sound loud or soft?
Loud. When I place the lid on it, it already gets softer, right?
Yes. As we pump the air out of the jar, what's happening to the sound? It gets softer.
I can even lift the jar up by the lid because of the air pressure outside forcing them together.
The reason is that there's little air in the jar and lots outside. I'm putting my hand over this nozzle here because the air from the jar is coming out from this nozzle. Once you stop feeling the air here, then that means there's no air left in the jar. Does anyone want to feel it?
Listen to the bell. Now it is much softer than before because the air has been taken out.
Air is a medium, and you need a medium for sound waves to travel through. You need a medium because the molecules in the medium bump against each other, which allows sound vibrations to travel to our ears.
Is the bell broken?
No.
The sound kept on getting softer because the medium was taken out. As Katie releases the air, the bell gets louder again.
I hope you've learned a lot about sound.
Thank you for listening.
Have a nice day.
Hi, my name is Mary Rose.
Hi, I'm Zoe.
What causes the pitch of the sound to change? Does anybody know?
Frequency of a sound source tells us how quickly or how frequent the sound is vibrating.
For our experiment, one of us will spin a bicycle wheel and put a note card in the spokes.
Did you notice that the sound changed when the wheel is spinning fast than when it's spinning slowly?
That's because when the wheel is spinning faster, the vibrations were more frequent, causing the sound to be higher.
And when the wheel is spinning slowly, the vibrations weren't as frequent, causing the sound to be low.
On our poster, we have model sound waves showing how pitch and frequency can change.
Frequency is all around you. For example, if somebody screams, it'll probably be loud and high. Versus if a tuba is played, it'll probably be softer and low.
I hope you learn a lot about frequency and pitch.
Thank you and enjoy your day.
Hi, I'm Audrey.
And I'm Francesca.
Would you like to learn about frequency?
Sure. Do you know what frequency is?
No. Well, frequency is how often the sound waves vibrate.
Now we're going to do an experiment. Can I have a volunteer?
Francesca will hold the wheel, and I will spin it first slow and then faster. And you hold no card between the bars. But before we do this, let's make a prediction. What do you think will happen when we spin the wheel faster?
The volume will be, the pitch will be higher. Let's see.
This is fast. So, what happened?
Pitch got higher. Exactly. As you spin the wheel faster, the vibrations are more frequent.
Any questions?
Well, thanks for coming. Bye.